Well, welcome back. Now we're in section 6.6, dealing with something called improper integrals. What exactly is an improper integral? Well, improper integrals are really defined based on two different types, a type 1 and a type 2. The type 1 improper integral is when you're integrating with bounds from some kind of number to infinity. You're having an infinity on the bound or possibly a negative infinity on the bound. So when you're trying to integrate to infinity. Now you think this is kind of bizarre, but remember, basic definition of integral with bounds is area under a curve. So you're trying to find the area under f of x from some particular point A to infinity. Now sometimes this will diverge and you'll get the answer diverges, but if it actually goes towards a number, we're going to say it converges to that number. But to be able to go to infinity, you got to turn this improper integral into a proper integral by replacing infinity with the limit is, like, pick a letter, t goes to infinity. So you have your standard integrate, plug in top minus plug in bottom. Then you're going to be doing back to calculus 1, taking the limits as in this case t approaches infinity. And we'll do some examples of this, but that'll be the type 1 improper integral. Have an infinity or possibly a negative infinity on the bounds. The other type of improper integral, what we call type 2, is it looks like a standard integral, but you're integrating it over a particular point, it may be on the bounds or inside the bounds, where the function does not exist at, where the function is undefined. So yeah, again, that means you're going to have to pay very close attention to the function and what is the domain of that function. And when you try to integrate over something that's not in the domain, that'll be a type 2 improper integral. But as you see, this is going to be dealing with some limits, so let's do some review of limits real quick here. Remember, when you take the limit as x approaches infinity or negative infinity of 1 over x to 1 over x, you go to 0. Infinity on the bottom, that makes you go to 0. And the limit as x approaches infinity of any kind of constant over x, where x is going to infinity. So the denominator is getting bigger, is going to go to 0. Also, when you take the limit as x approaches infinity of 1 over x to the n. It doesn't matter. Any kind of positive power will always be equal to 0. A few other limit rules from calculus 1 you're supposed to have memorized is the limit as x approaches 0 on the plus side of the natural log of x. That'll be equal to negative infinity. The limit as x approaches infinity of the natural log of x will be infinity. The limit as x approaches infinity of e to the x, that gives you infinity. However, the limit as x approaches infinity of e to the negative x, well, that means you'll be getting negative infinity as the exponent. That'll go to 0. And a couple more. The limit as x approaches infinity of the arc tangent or tangent inverse of x, that'll be pi halves. And the limit as x approaches negative infinity of the arc tangent of x or tangent inverse of x, that'll be negative pi halves. So in layman's terms, remember this. 1 over infinity, that's equal to 0. 1 over negative infinity, that's still equal to 0. Natural log of infinity is infinity. However, the natural log of 0 on the plus side will be negative infinity. E to the infinity is infinity. E to the negative infinity is equal to 0. The tangent inverse of infinity is pi halves, and the tangent inverse of negative infinity is negative pi halves. These are some of those basic rules that, again, we have memorized. This is kind of my shorthand notation for this limit information, again, from Calculus 1. So let's take a look at some examples here. All right, so our first question here is this. Determine whether the improper integral, the integral from 3 to infinity of 5 over x dx, evaluate it and find if it is convergent. If it's divergent, we would say a divergent. Divergent means it blows up to infinity or negative infinity. If it's convergent, it means it goes to a particular number. So we got to figure out if this thing actually is convergent, and if we do, we need to evaluate it and then figure out what it comes to. But if it's divergent, we would say, blows up to infinity, we would just call it divergent. Now, this is the properness of doing improper integrals. We're integrating from 3 to infinity of 5 over x dx. What makes this improper is this is what we call a type 1 improper integral. We have the infinity on the bound. So, to make it proper, we would say This will be equal to the limit. Pick your favorite letter. We're all shooting for A's in this class. The limit as a approaches infinity of the integral from 3 to a, 5 over x dx. So you've got to replace this infinity with a limit and pick it with a letter. Limit as a approaches infinity from, this is a fine number 3, up to, and replace infinity with a. So now we're going to do our calculus. This will be the limit as a approaches infinity, and we keep writing the word limit until we actually plug in the limit, plug in the number, and then we evaluate it. But we still got integrating this thing. What's the integral of 5 over x? So 5 is a constant, leave it alone. Integral 1 over x dx is the natural log, officially absolute value of x, evaluated from 3 to a. So according to the fundamental theorem of calculus, we plug in top minus plug in bottom. So this will be the limit as a approaches infinity of 5 times the natural log of a minus 5 times the natural log of 3. But now we evaluate. Now I'm going to replace a with infinity. This is 5 times the natural log of infinity minus 5 natural log of 3. But as we just mentioned a few seconds ago, and I'll pull up this little paper as we talked about it, the limit as x approaches infinity of the natural log of x equals infinity. In other words, the natural log of infinity is equal to infinity. So this thing is going to infinity. So I get infinity minus 5 natural log of 3. 5 natural log of 3 is just some kind of a number. So infinity minus a number is infinity. So we would say the answer to this integral is divergent. In other words, if you actually graph this thing, the graph of 5 over x looks something like this. Y equals 5 over x. And you're starting at 3 and you're going towards infinity here. In terms of trying to calculate the amount of area under the curve, since this thing keeps on going and you keep adding on just that little bit more area, you never actually converge to a particular number. The area just keeps getting bigger, bigger, and bigger. This is the idea that's going on. But the other idea that you need to focus on in doing improper integrals is showing the steps. To turn an improper integral into more properness by replacing the infinity with the limit as, in this case, a approaches infinity, and make it the integral from 3 to a of your function. You integrate, you evaluate it, plug in top minus plug in bottom with this arbitrary variable, and then you take that variable, limit as a approaches infinity. Then we go back to calculus 1 by doing limits, take the limit as a approaches infinity, plug it in, and let's see what we get. If we get a number, we would say it converges. If we get infinity, we say it diverges. So let's take a look at this particular problem. You'll notice that I just changed one little bit of this one. This problem up here was the integral from integral from 3 to infinity of 5 over x dx. However, the problem of this one is the integral from 3 to infinity of 5 over x squared. By putting that little power on there, does it actually change my problem? Well, let's take a look. Again, you will notice that this problem is improper. So this integral from 3 to infinity of 5 over x squared dx, that will be equal to, well, we don't like infinity, so now we make it proper by doing our limit. Limit, I like my favorite letter A, approaches infinity of the integral from 3 to a of 5 over x squared dx. But you understand, this is still in chapter 6. And chapter 6 is about integrating. So we need to integrate this guy again. So we're going to continue to practice our integral skills, but if I'm going to integrate this guy, I'm going to clean it up. So I'm going to take the limit as a approaches infinity of the integral from 3 to a of 5x to the negative 2 dx. Clean them up first. Now let's integrate them. So you'll notice that I'm making it very proper. I keep writing the word limit as a approaches infinity. Now let's integrate. 5 integral x to negative 2 is add 1 x negative 1 over negative 1 evaluated from 3 to a. Now I'm going to apply fundamental theorem of calculus, but first I'm going to clean this up a little bit more so I can see what's going on. This is the limit as a approaches infinity of negative 5 over x evaluated from 3 to a. Now apply the fundamental theorem of calculus. This is the limit as a approaches infinity of negative 5 over a minus negative 5 over 3. Plug in top minus plug in bottom. Well, this cleans up to be the limit as a approaches infinity of negative 5 over a plus 5/3. Now, the last little thing we do is finally do the calculus 1 thing and take the limit as a approaches infinity. Remember, this is a number divided by infinity. As infinity gets bigger in the denominator, my overall fraction goes to 0. So I end up getting 0 plus 5/3. We no longer write limit once I actually evaluate the limit. So as a goes to infinity and the infinity is in the denominator, my overall fraction goes to 0. So this is equal to 5/3. So therefore, we would say the answer is convergent to 5/3. If we get a number, we call it convergent. If we get infinity or negative infinity, we call it divergent. So not too bad on these problems, but it does remind you you're going to have to go back and do some calculus 1 stuff. So let's look at some more problems. Let's try these. On this particular problem here, it says this: determine whether the improper integral from 2 to 11 of 5 over the square root of x minus 2 dx is convergent or divergent, and if it's convergent, find what it's evaluated. So here we go. Now, the first thing you've got to notice is this. This is what we call a type 2 improper integral. And what I mean by type 2 is this. We don't have infinity on the bounds. That's type 1. The fact is, this guy has a problem when x is equal to 2. The reason why? 2 minus 2 is 0. The square root of 0 is 0. And you can't divide by 0. So my problem point on this one is actually on the bound. But whether it's on the bound or inside the bound, it's called an improper integral. If it's outside my integral, I don't care about him. But if I'm trying to integrate over or next to a point that does not exist on the function, well, that's called an improper integral type 2, which means you've got to pay attention to domains of particular functions before you integrate them. But we're going to do the same thing. We're going to convert this problem into, pick our favorite letter, limit as a approaches, but this time we're going after 2. But we got to be particular. We're trying to integrate from 2 up to 11, so we're on above 2. So we're going to take the limit as a approaches 2 on the plus side. And the reason for the plus side is because you're integrating from 2 up to 11. So all my bounds are above 2 as I'm integrating it. Of my function, the integral, replace 2, the problem point, with a to 11 of 5 over the square root of x minus 2 dx. Now let me just be clear here that I like picking A's. I'll use A, B, and C in my classes or whatever, but your professor may choose different letters. You can pick whatever letter you want to have. You're just taking the limit as plugging a letter in for your problem point, and then take the limit as that letter goes to, in this case, 2 from the plus side. Well, I'm going to clean this guy up first before I integrate him, because this is all about integration. Take the limit as a approaches 2 from the plus side of the integral from a to 11 of 5 times x minus 2 to the negative 1/2 dx. Now, if I'm going to integrate this thing, I'm going to use u substitution. U would be equal to x minus 2. du equals dx. So this would turn into the problem. 5's a constant, it holds over. This is u to the negative 1/2 du. Integrate him. This is 5u to the add 1, 1/2 over 1/2. Cleaning them up, invert multiply. This will be 10 square root of u when you clean them up. And when I back substitute, that'll be 10 square root of x minus 2. So this was all to just integrate this guy. So this would be equal to, back substituting, the limit as a approaches 2 from the plus side of my answer, 10 square root of x minus 2, evaluated from a to 11. Well, according to the fundamental theorem of calculus, I will plug in top, limit as a approaches 2 from the plus side of 10 square root of 11 minus 2, minus, plug in bottom, 10 square root of a minus 2. Cleaning them up, this is the limit as a approaches 2 from the plus side of 10 square roots of 11 minus 2 is 9 minus 10 square roots of a minus 2. Well, the square root of 9 is 3 times 10 is 30, so this is equal to the limit as a approaches 2 from the plus side of 30 minus 10 square roots of a minus 2. So I did all this work just to clean up my number, but now the last thing I got to do is take the limit as a approaches 2 from the plus side of 30 minus 10 square roots of a minus 2. Well, first rule of limits, plug in a number. So when I plug in a number, this will end up giving me 30 minus 10 square root of 2 on the plus side minus 2. 2 on the plus side minus 2 is 0. And the square root of 0 is 0. So this whole term cancels. So you're left with 30 minus 0, which is equal to 30. Since I have a number that I got when I did my limit for my integral, this improper integral, we would say, therefore, the answer is convergent to 30. The convergent or divergent lets us know it was an improper integral to begin with, and if it converges to 30, that means I actually got a numerical value out of it. If it diverges, that means I either got infinity or negative infinity out of it. But notice all the properness of my work. It's about showing your work. And we can get the answer, but you must show the techniques of limit, 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 and as you work the problem out. Let's take a look at this last one. Same kind of problem here. I've got the integral from 3 to 10 of 7 over x minus 5 dx. And we're supposed to evaluate it. If it's convergent, tell me what it converges to. If it diverges, tell me it diverges here. But notice something here. This guy has a problem. This function that I'm trying to integrate, 7 over x minus 5. The problem point is at x equals 5, because at 5 I would be dividing by 0. And you will notice that 5 is in the middle of my integral. I'm trying to integrate from 3 to 10. So here we go. What you're going to have to do this problem is you're going to have to break this guy up. So the integral from 3 to 10 of 7 over x minus 5 dx will be equal to, now I'm going to have to break up because my 5 is right down here in the middle. So this would be the limit. First off, we'll integrate like this. Integral from 3 to 5 of 7 over x minus 5 dx plus the integral from 5 to 10 of 7 over x minus 5 dx. Now I've broken up my integral over my problem point because I have to skip over my problem point because the function doesn't exist there. Which means my type 2 improper integral is actually turned into 2 type 2 improper integrals here. And so I'm going to do this problem, I'm going to do one of each time. All right, so the integral, so this first part, let's just call this the first part, the integral from 3 to 5 of 7 over x minus 5 dx would be equal to the limit as x approaches 5. I'll just pick a different letter, a. A approaches 5. I'm going from 3 up to 5, so I'm actually slightly below 5. So the limit as a approaches 5 from below of the integral from 3 to a of 7 over x minus 5 dx. And the other part would be the integral from 5 to 10 of 7 over x minus 5 dx, which I would pick a different letter. That would be equal to limit as, let's say, b approaches 5, but I'm integrating from 5 up to 10, so that's on the plus side now, from 5 up to 10, of the integral from b to 10 of 7 over x minus 5 dx. Now it's got two different problems, so and if I'll get an answer for this guy, I'll get an answer for this guy, so to get an answer for the whole thing, if this converges, it goes to a number. If this converges, it goes to a number. I would add the two numbers together, and then this integral would converge to the sum of these two answers. However, if just one of these two integrals diverges, I don't care what the other guy does. If this guy diverges and this one's convergent, who cares? Well, infinity plus 5 is still infinity. So if just one of these two integrals diverges, the whole answer for my problem is going to be diverges. So let's integrate this thing. So this will be the limit as a approaches 5 from the minus side of, well, this kind of integral you should do in your head. I'm trying to integrate 7 over x minus 5 dx. It's u substitution in your head. You would let u equal to x minus 5. That means du is equal to dx. So this is 7 over u du, which becomes 7 natural log absolute value of u, which is x minus 5. So easy u substitution in your head integration here, evaluated from 3 to a. So here we go. This is equal to the limit as a approaches 5 from below of 7 times natural log of the absolute value of a minus 5 minus 7 natural log of the absolute value of 3 minus 5. Let's clean this up. This will be the limit as a approaches 5 from below of the natural log of the absolute value of a minus 5 minus 7 natural log of, now 3 minus 5 is negative 2, but it's absolute value. Absolute value of negative 2 is positive 2. So now all you got to do is evaluate, plug this thing in at 5. Now 5 from below minus 5 is 0 from below. So this is actually natural log of 0 from below. But the absolute value of 0 from below is natural log of 0 from above. And if you go back to that front page, this is when we told you these guys. The natural log of 0 on the plus side is negative infinity. So this becomes negative infinity minus 7 natural log of 2, which is negative infinity, which means it is divergent. So this first integral between 3 and 5 of this problem is divergent. As I said before, if one of these two guys diverges, I don't care what the other guy does. He can converge or diverge. He'll also diverge, by the way. But if just part of it diverges, the whole thing diverges. So, therefore, the answer to this problem, therefore, and again, I'm not even worried about this problem, the integral between 3 and 10 of 7 over x minus 5 dx is divergent. Again, if this did converge, then I would go and figure out this integral. And if this did converge, I would add the two answers together. But if just one of them diverges, the original problem, the solution would be divergent. I hope this has been helpful, and I'll see you guys on the next video.